Good afternoon.
Good afternoon, sir.
Okay, so do you remember what we were discussing yesterday?
Yes, sir.
So we defined monotone sequence, and we saw the statement of theorem that which is monotone convergence theorem. A monotone sequence or monotonic increasing sequence, if it is bounded above, then it is convergent, right? And if sequence is monotonic decreasing and bounded below, then it is convergent, correct? So I gave you some examples yesterday. I hope you tried to solve these examples, right? Now look at this example. So x1 is 1 and xn plus 1 is 1 by 2 xn plus 2 by xn, right? So do you understand what are the terms of this sequence, right?
Yes, sir.
Yes, sir.
Okay, for example, what is x2? Right, so x1, 1 by 2 x1 plus 2 by x1. So what is it? 1 by 2, 1 plus 2 upon 1. That is 3 by 2, right? Similarly, you can understand what is x3, what is x4, and so on. Now, what is x3? What is x3?
1 by 2 into 3 by 2 plus 2 by 3 by 2.
Right, so 3 by 2 plus 4 by 3, right? And whatever is this number, 1 by 2 into 9 plus 8, 17 by 6 is 17 by 12. So basically, you see that all xn's are rational numbers. Why I am saying rational? Because they are rational numbers, and why it is important, that we'll understand later on. Okay, now first of all, we'll try to check whether it is monotonic increasing or decreasing, right? And then we'll think about limit, right? So what is xn plus 1? Xn plus 1 is 1 by 2 xn plus xn plus 2 upon xn, which is xn plus 1. Fine. So now we want to check whether it is monotonic or not. Then we'll see whether it is bounded or not. Okay, so try to simplify this. 2 times xn plus 1 is equal to xn plus 2 upon xn. Okay, so simplify further. Multiply both sides by xn. I am looking at particular xn n. So 2 times xn plus 1 into xn is equal to xn square plus 2. You check the calculation. If I am going wrong, please inform me. Right?
Yes, sir.
Xn square minus 2 times into xn plus 2 is equal to 0. Now, what are the xn in this case? What are the xn? Real numbers, right? Basically, xn's are real numbers. Right? Xn are terms of sequence. So this is equation in a quadratic equation in Xn. So right, this is a quadratic in Xn, right? So and Xn's are real numbers, and therefore what is Xn for from this expression? What is equation Xn from this?
2 plus or minus under root of 4 minus 2.
Right. Suppose you have quadratic equation, then x is minus b plus minus discriminant. Right. So discriminant. So what is here? 2xn plus 1 minus square root of 4xn plus 1 square minus 4 into 2. Am I right?
Yes, sir.
Divided by 2. So since xn's are real numbers, okay, let us go to the theory of quadratic equations. What can you say about quadratic equation? Suppose you have quadratic equation ax square plus bx plus c is equal to 0. What are the roots? X is equal to minus b plus minus b square minus 4ac. Right. So these are the roots. When roots are real numbers, what is the characterization? What is the
B
discriminant?
square is greater than 4ac.
So b square minus 4ac discriminates whether root is real or complex number, right? If this is greater equal 0, right, then x is real number, or x is real number, then b square minus 4ac must be greater equal 0. If b square minus 4ac is negative, then roots are complex, right? So that's why it is b square minus 4ac is called as a discriminant, because it discriminates, right, among the roots, whether root is a positive or negative, that is discriminated by this discriminant, right? Okay. So xn is all terms are real numbers, that we are sure, and therefore what we can say about the discriminant? We have the discriminant. What is the discriminant in this case? 4 times must be greater equal 0. Correct?
It will be minus
Sorry,
2, no?
2. Yes.
Minus
Minus 2. Xn plus 1 square
Oh,
minus 2.
right, minus 2. So here it should be minus 2. So 4 times xn square minus 2 must be greater equal 0. But 4 is already positive quantity. So xn plus 1 square minus 2 is greater equal 0. That means xn plus 1 square is greater equal 2. Right, xn square plus. So that means xn plus 1 is greater equal root 2. Right. So again, note one thing. When I say x square is greater equal a, what does it mean? Either x is less than or equal to minus a, or x is greater equal a. Is it clear?
Yes, sir.
Sir, we can also say that xn plus 1 lies between minus root 2 to root 2.
No. Not less than root 2. It is greater than or equal to root 2. Why you can say less than? Because
Why we are not taking the minus root 2 in this case?
So that's my
yes.
question.
So why not negative? Because that's why I am saying x square is greater equal a. That means there are two possibilities. Either x is less equal minus a. Right. For example, when I say x square is greater equal to, what are the possibilities? For example, 3. 3 satisfies this. Minus 3 also satisfies this. Right.
Yes, sir.
That means x is greater equal to or x is less equal minus 2. Two possibilities. But why we are not taking negative? Because what are our numbers? All numbers are positive. That is by definition of sequence. You understand?
Yes, sir. Got it.
So observe that in this case, all xn's are positive. Therefore, negative choice is not there. Right. Therefore, xn plus 1 is less equal minus root 2 is not possible. In this case, because we have defined already, we are talking about particular sequence. So in this case, negative case is discarded. So only the possibility is xn plus 1 is. This is true for all n. Right. Therefore, xn plus 1 is greater equal root 2 for all n. That means for all n means n is equal to 1 to infinity. So therefore, all xn are greater equal root 2 for all n greater equal to. Right. X1 is not an issue because it is a constant, and therefore can we say that xn is bounded below?
Yes, sir.
So certainly xn is bounded below because we saw that 2 onwards certainly terms are greater equal root 2. No matter whatever is first term, still it is a finite number. So there is no harm in saying that xn is bounded below. Fine. Okay, so sequence xn is bounded below. Next. Consider xn minus xn plus 1 difference. Now we are sure that X sequence is bounded below if you are able to prove that sequence is decreasing, right? Then from that, can you conclude that sequence is convergent?
Yes, sir.
Yes.
Right. If somehow we are able to prove that sequence is decreasing, already we know that it is bounded below, then certainly we can say that it is convergent. And then we'll think about limit. Okay, let us see what happens. Xn minus, but by definition, what is xn plus 1? Right? Xn minus half xn plus 1 upon xn. So what is it? Half xn plus 1 by xn. Correct?
So it will be minus 1 by xn.
Why?
Bracket.
Bracket. Okay. So if you remove the bracket, then here it will be minus. Right. Okay, then xn square minus 2 upon 2xn.
Yes, sir.
Right. Okay, so xn square minus 2 upon 2xn. Can I say that this quantity is greater equal 0 for all n greater equal to certainly?
Yes.
Yes.
Yes, sir.
So second, because we already verified that ki xn minus xn square minus 2 is greater equal 0 for n greater equal to. For first term, not an issue. Why that will, first term doesn't matter because it is a single term. Therefore, xn minus xn plus 1 is greater equal 0 for all n greater equal 2. That means xn plus 1 is less than or equal to xn n greater equal to. Neglect first term, that is not an issue because first term doesn't matter. We are interested in what happens at infinity, far away from first term. Therefore, first few terms doesn't matter as far as the convergence is concerned, right? Do you understand what I want to say?
Yes, sir.
Right, so we are not worried about first term. So certainly after second term onwards, terms are decreasing, and therefore I can declare that key xn is monotonically decreasing. Correct?
Yes,
So,
sir.
and therefore already we have verified that it is bounded below. Right? Already we have verified that it is bounded below. Right? So, and what is the conclusion? Thus, xn is monotonically decreasing and bounded below, and hence convergent. Right?
Excuse me, sir.
Yes.
Sir, but x1 is also a term of the sequence only, no? So why are we not considering that?
Doesn't matter for convergence. Okay, let me give you example. You know, okay, so first term doesn't matter basically. Suppose what is limit of sequence 1 by n?
0.
0.
Right. Okay, now I will give you one more sequence yn. What is yn? 100, 500, 120, then 1, 1 by 2, 1 by 3, 1 by 5, and so on. 1 by 4, 1 by 5, and so on. All the 1 by n terms. What is limit of this new sequence yn?
Um, 0 only.
0, because what happens at infinity? As n, when I say limit, means limit of yn as n tends to infinity. So we are looking at what happens at infinity. Therefore, doesn't matter what are first few terms, 100 or 5,000 or 1 crore, 3 terms doesn't matter. Do you understand this?
Sir, but in that monotonic decreasing function, we have considered, sorry, not function, sequence, we have considered that each term is greater than the previous term. But it is not so in this case, no?
No, no, no. See, what is the problem? First term doesn't matter. So, okay, you want to modify the situation. After second term onwards, we are sure key terms are decreasing.
Yes, sir.
Right. And if after second term terms are decreasing, or after some 100 terms are decreasing, then also we can say that, okay, actually it is called as eventually decreasing. You can say after certain thing the terms are decreasing, so eventually decreasing. But if it is bounded below, it is convergent, the result is same. Convergence is not affected if you change previous initial sum terms. Right.
So then in the alternating sequence also it is first decreasing, increasing, then
No, which alternating sequence?
Like we have minus 1 to the power n, that sequence.
So it is not eventually decreasing. Minus 1, 1, minus 1. There is no situation in terms start decreasing. Does such situation arise? Such point
No,
arise?
no, sir.
Right? No.
Yes, sir, I got it. Okay.
In Yn, there is a situation. 4 term onwards, terms are decreasing and then continuously decreasing and bounded below, so conversion.
Yes, sir.
Right. So the point is you should understand that when we talk about limit of a sequence, we are interested in infinity. What happens at infinity? Far away. Therefore, first few terms, whatever, doesn't matter, doesn't affect the limit. You see this example 1 by n, 1, so limit is 0. Sequence 1 by n converges to 0 and yn is a new sequence, but still limit is 0. Right? Because if you change first few terms, in first sequence, first term is 1, but in second sequence, first term is 100. In this sequence, second term is 1 by 2, but here second term is 500. So first few term doesn't affect.
Okay, sir.
So, and therefore, what happens about x1, that is not an issue. Right? 2 onwards terms are decreasing and sequence is bounded below. Then we can say that it is conversion. Correct?
Yes, sir.
Okay, so now we are sure that limit exists. So let x is equal to limit of xn. Therefore, what is limit of xn plus 1? Can I say that limit of xn plus 1 is same as xn limit of xn?
Yes, sir.
Right? Because x1, x2, x3, when I say xn as n tends to infinity and xn plus 1 as n tends to infinity, just the first one is a one step ahead of xn, but destiny is same because they both follow the same sequence. Right? Is x. So, and what is xn plus 1? Right? Because xn plus 1 is this. And so limit is this. But what is limit of right hand side? What is limit of right hand side?
Root 2.
1 by 2 limit of xn plus limit of 2 upon xn. Right. But what is the limit of xn plus 1 is x half. And what is the limit of xn is also x plus limit of 1 upon xn is 1 upon limit of xn. So algebra of limits that you can use here. Correct? Right. Now what is it? 2x is equal to x square plus 2. That means x square minus 2x plus 2 is equal to 0. So solve this quadratic equation for x. What is x? 2 plus minus square root of 4 minus 4, 8, right?
Sir, in the left hand side, it will be 2x square.
Oh, right. 2x square. Why 2x square? Right, 2x square. Okay, so what is it? 2x square minus 2x plus 2 is equal to 0. So what is limit? What is solution of this quadratic equation?
Sir, I actually said that left hand side will be 2x square in the second step. It will be x square plus 2 only.
Yes.
Sir, x is equal to root 2.
Yes, root 2.
2x square is equal to x square plus 2, right? That means x square is equal to 2. That means x is plus minus root 2. There are two possibilities, right? When x square is 2, then x is either plus root 2 or minus root 2, right? But x is equal to minus root 2 is not possible. Why?
All terms of xn are positive.
Right. So since xn is greater than 0 for all n, and therefore limit of xn is greater equal 0, this result we have already proved, right? So limit cannot be negative, and hence only choice is x is equal to plus root 2. Therefore limit of xn is root 2, right? So this sequence converges to root 2. Now this is a very interesting or important problem, because so what we defined, x1 was 1 and xn plus 1 was half xn plus 2 upon xn. This was our sequence. Then xn is a sequence of rational numbers. Is it true?
Yes, sir.
Because each xn is a rational number, you check it. Because x1 is a rational number because x1 is 1, and what is x2 is a combination of xn and some numbers integer. So therefore the next term is combination of previous term in terms. So previous is a rational, so next is a rational. Right. From that you find next term, because previous was rational, next term is rational number. So that is easy, right? So xn is a sequence of rational numbers. But what is a limit?
Irrational.
Limit is irrational number. But limit of xn, which is root 2, is an irrational number. Right. That means there exists a sequence of rational numbers which converges to irrational numbers. That happens actually, right? Correct?
Yes, sir.
Right. Now, question I would like to ask. Given a rational number, can you find a sequence of, so given a rational number R, can you find a sequence of irrational numbers converging to rational number R? Do you understand the question?
Yes, sir.
For example, if I give you rational number R is equal to 7, can you find a sequence xn of irrational numbers which converges to 7? And there are many actually, but simplest one is right. What is the limit of xn?
7.
7. And what is xn? Each xn is irrational number. Is it correct?
Yes, sir.
Right. So limit is a rational number, but the terms are irrational numbers. And in previous case, what we found, terms are rational numbers, but limit is irrational number. So all these possibilities are there. Right. And that means what? What actually we are doing by the sequence? What actually we are doing? By what sequence does? Because what is the first term of this sequence? What was the first term of the sequence? 1. Forget about first term. What was the second term? What was the second term? If you go back, what was the second term?
3 by 2.
3 by 2, right? So 3 by 2, second term. And then we know that terms are decreasing. The third term is somewhere here and so on. But ultimately root 2 is here. And our sequence was decreasing, so it will go to root 2. So what actually happening? What this sequence does? We are here, second term is 3 by 2, third term is somewhere here, fourth term is here, fifth term is here. That means we are going closer and closer to root 2. So these terms actually gives approximations, right? Terms actually gives approximation or approximate values of root 2. So from the definition of sequence xn, what is x2? What is x2? 3 by 2. 3 by 2 means 1.5. What is x3? What is x3?
17 by 12.
17 by 12. What is x4? And if you calculate the error, what is the error? Actual number is root 2 and x2. What is the error? 3 by 2. Whatever is the error. Root 2 minus error. Root 2 minus x2. Whatever is error, and root 2 minus x3, this error. Which error is small?
Second one.
Right, so second error is small. That means x3 is very more closer, more approximate. Correct? If you find
Yes, sir.
x2, what is x4 now? You calculate x4. x4 is a more closer to root 2. Right? x5 is still more closer to root 2. That means, so the sequence, the terms of xn gives approximate value of root 2. So with this sequence, we can actually approximate value of root 2, because root 2 is irrational number and we cannot get exact value of root 2, but we can approximate. And how to get more correct approximation, more closer value to root 2, right?
We approach greater terms.
So choose larger n, and since our sequence was decreasing, right, and terms are going towards root 2, that means if you choose larger n, will be very close to root 2, and therefore that value corresponding, suppose you choose n is equal to 150, then look at the corresponding term x150, that number is a very close to root 2. If somebody tried to choose n is equal to 1565, then look at the corresponding term, that value is a very close to root 2. Correct? So convergence makes sense. Why we are studying this business convergence? There are many processes going on in real life problems, and we are trying to reduce error. We are trying to approximate something. Right? There is no model, no instrument available which is 100% accurate. Whatever instrument you select, we are using in daily life. whichever instrument, whichever gadget, whichever technology based instrument, there are always errors, and people are trying to minimize the errors, right? And so to minimize the error, you have to go to next term. What is the next term, which is close to the exact expectation, more accurate expectation, right? That is what this sequence important, right? Correct. Now, second point is can you approximate root 3? How can you approximate root 3? Right, so you can find approximate value of root 2 in this way. Just choose larger and calculate corresponding term. That will give more and more correct value of root 2. Right. So if a is a positive number, and if you select x1 as any positive number, choose x1 as positive number, no matter you select half, 1/5, or whatever positive, and define xn plus 1 is equal to 1/2 xn plus a upon xn. Then show that xn is decreasing, xn is bounded below, xn is bounded below, xn is convergent, and limit of xn is root a. Limit of xn is square root of a. And therefore, which number plays a role? Here, this number plays important role, right? A upon xn. Now, can you produce a sequence of rational numbers which converges to root 3? Now you tell me the sequence of rational numbers which converges to root 3.
So if we choose a is equal to 3, then
Right. If you choose a is equal to 3, then that sequence definitely, and each term is a rational number. Remember. Right, so you work out this exercise just similar to the previous problem. Exactly similar. Only 2 is replaced by a, and all the calculations are similar, right? So we cannot actually calculate directly limit unless we ensure that limit exists, right? So remark third, if y1 is equal to 1 and yn plus 1 is equal to 2 times yn plus 1. What can you say about this sequence? See, can you say that all yns are greater than 0?
yes.
So if limit of yn is y, then what is limit of yn plus 1 is limit of 2 times yn plus 1. We don't know whether limit exists. Suppose limit is y, then what will happen? Y is equal to 2y plus 1 means what? Y is equal to what? Minus 1. Is it possible?
No, sir.
No, sir.
Not possible. Why?
Because the
Because
terms
yn
are
contains all positive terms and it is increasing sequence.
Right. So therefore, what is the conclusion? What is the conclusion? Yn is not convergent. If we say it is convergent, then there is a contradiction. Ki y is minus 1, right? So it is not convergent. Therefore, directly looking at the expression, you cannot calculate limit, right? Suppose you directly apply limit and then, like in previous example, y is equal to 2y plus 1, then y is minus, so minus 1 is, that is not possible. Previous examples, we could do this because we were sure that it exists, right? So, and why limit does not exist? Because it is a monotonically increasing and not bounded above. So this sequence is not convergent. That is a reason, so that you can check. But the point is, you cannot directly apply limit. That is the main point. You should remember always. Do not apply directly limit unless you are sure that limit exists. Otherwise, you will get some wrong conclusion. Right?
yes, sir.
Okay, let y1 is equal to 1. Yn plus 1 is equal to 1 by 4 plus 3. Then discuss the convergence of sequence y. And discuss the convergence means check whether it is convergent. But to ensure that it is convergent, check whether it is monotonic, increasing or decreasing. If it is increasing, check whether it is bounded below or bounded above. Right? And then say that it is convergent or not. That is, what you need to check is prove that yn is increasing. Second point, prove that yn is bounded above. In this case, it is increasing, but not necessary every time increasing. So we have to check, find limit of yn. Right. So procedure is clear. Procedure is clear. Right. So there should not be confusion in the process. Okay, so and you can work out the calculations with similar manner. So let's suppose xn is this. Right, so what is the first term of this sequence? 1. Right? What is second term?
Sir, in the above question,
Yes.
sir, do we use induction to prove that it is bounded above?
Yes.
Okay.
Exactly.
Okay.
If you want to prove that yn is less equal some number for all n, that means you want to prove something for all natural numbers. That means
Okay.
naturally you should think about induction.
Okay.
What is x3? 1 plus 1 by 2 plus 1 by 3, which is 3 by 2 plus 1 by 3, which is 10 by 6. Right? These are the terms. Now, is sequence xn monotone? Is it monotonic sequence?
Yes, sir.
Yes, sir.
Yes, because if you look at xn plus 1 minus xn difference, 1 plus 1 by 2 plus 1 by n plus 1 by n plus 1, this is xn, minus 1 plus 1 by n, this is x. So up to 1 by n all are common numbers, so they get cancelled, and what remains 1 by n plus 1, which is positive quantity. Therefore xn plus 1 is greater than xn. This is true for all n. Right, it is clear. Here don't need induction, directly we get it. Right? Therefore xn is monotonic. Increasing. So tendency of this sequence is increasing, right? Now what guarantees the convergence?
Only if it's bounded, then it will be convergent.
If it is bounded above. But now tendency of this sequence is increasing, and if there is no number which control the terms or no not bounded above, what will happen?
It will be divergent.
So it will be divergent, but it will diverge to plus infinity. It will actually, because divergence are two types, right? Either it goes to infinity, or it goes to minus infinity, or it remains oscillating like minus 1 raised to n, right?
Yes, sir.
Right, and since the tendency of this sequence is increasing, if it is not bounded above, then certainly it will go to plus infinity. But we'll check whether it is bounded above or not bounded above. That will give us definite information, right? Okay, so what we can do? What we can do? So consider x2. What is x2? Right? 1 plus 1 by 2. Correct?
Yes, sir.
What is x4? Plus 1 by 4. Now I'll group this 1 by 3 plus 1 by 2. Now 1 by 3, 1 by 4, which is smaller?
1 by 4.
1 by 4.
1 by 4 is smaller. So I'll replace 1 by 3 by 1 by 4. And therefore the resulting quantity is smaller. Correct?
Yes, sir.
Right. And therefore I will get 1 plus 1 by 2 plus 2 by 4, which is 1 plus 1 by 2 plus 1 by 2, which is 1 plus 2 by 2. For instance, keep it is at 2 by 2. For instance, keep it as it is. So 2 by 2, 1 plus 2 by 2. Right. Now look at x8. Look at x8. 1 plus, right, plus 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. Now I will group in this way, 1 by 3, 1 by 4. Right, so up to this, no problem, we have already calculated. And after this pink and green, you understand? Up to 1 by 4, this amount is greater than 1 plus 1 by 2 plus 1 by 2, correct?
Yes, sir.
Now what is the next? In next bracket there are 4 terms, and which is the smallest?
1 by 8.
1 by 8. So I will replace everything by 1 by 8. And therefore of course the resulting quantity is smaller, right? That's why I'm saying it is less and the previous one is larger. Right, so 1 plus 1 by 2 plus 1 by 2 plus 4 by 8 is what?
1 by 2.
1 by 2. So therefore 1 plus
1
how
by
many,
2.
how many times 1 by 2? 3 times 1 by 2. Correct? Do you understand what I want to say?
Yes, sir.
So can you identify some pattern? Do you identify some pattern?
Yes, sir.
X8, x2 raised to 3 is greater than 1 plus 3 upon 2. Do you understand?
Yes, sir.
So x4.
परत सांगता का please?
What is x8? x8 is x2 raised to 3. 8 is 2 raised to 3, right?
Yes, sir.
And we already proved that x8 is greater than 1 plus 3 by 2. That means x2 raised to 3 is greater than 1 plus 3 by 2. Right? Because 8 is just, I am writing in a different form. 2 raised to 3, 8 is 2 raised to 3. Similarly, look at x4. x4 is actually x2 raised to 2. 4 I am writing in terms of 2, 2 raised to 2. But we have already verified that it is greater than 1 plus 2 by 2, power of 2. Which is, can you tell me now what is x16? x2 raised to 4 actually, 16. Is it greater than 1 plus 4 by 2?
Yes, sir.
Yes, sir.
Yes, sir.
Right, now prove by induction. So we can actually prove, you just try to prove, we can prove by induction that x2 raised to n. What is x2 raised to n? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Just look at the bracket. 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8 and so on. So the first bracket is of 2 terms, second bracket is of 4 terms, next bracket is of 8 terms. 1 by 9 to, what is the next bracket? 1 by 9 to what? 1 by 60. Continue this bracketing, and what will be the last bracket? See, in case of x8, what are the brackets? 1 plus 1 by 2, 1 by 3 plus 1 by 4, and last bracket is up to 1 by 8. And what is the first term in the last bracket? 1 by 5. Right, what is 1 by 5? 1 by 2 raised to 2 plus 1. And what is the last term? 1 upon 2 raised to 2 plus 1. Do you understand? This pattern you have to observe.
Yes, sir.
Yes, we understand difference. 1 upon 2 raised to 2 plus 1 and last term is 1 upon 2 raised to 2 plus 1. The difference. Plus 1 is in the exponent, plus 1 is in the base.
Sir,
Yes.
sir, if we would have taken 1 by 8 in all the terms, then
1 by 8.
in all the terms in this x8, then
So that doesn't give us concrete information. You can try later on. We will
okay.
give you some concrete information. So we want some concrete information. That's why we are using this criteria. Anyway, what should be the last bracket from your observation? Because x in x8 last number is 1 upon 8. In x100, what is last number? Something plus 1 upon 100, right? Right. In x2 raised to n, what is the last number? 1 upon 2 raised to n. And if you group the terms in the manner which we did in previous calculations, so what will be the last bracket?
1 by 2 to the power
1
minus
upon 2
1.
raised to n minus 1 plus 1.
Plus 1. Okay. And so on. In between, everything is there. Right. Now, if you make the adjustment, then this bracket is what? 1 by 2. Each bracket we can say that each bracket is greater than 1. Each bracket is greater than 1. So, therefore, 1 plus 1 by 2 plus. So, 1 by 3 plus 1 by 4. Is it greater than 1 by 2?
No.
Yes, sir.
Right? Because 1 by 3 is greater than 1 by 4 and 1 by 4 as it is. So this is 2 by 4, which is 1 by 2. So 1 by 3 plus 1 by 4 is greater than 1 by 2. Now 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. Is it greater than 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8?
Yes, sir.
It is 1 by 2. So each bracket is greater than 1 by 2. And so how many brackets? How many brackets are this?
N brackets.
N brackets. Very good. Because in x8, in 2 raised to 3, there are 3 brackets. 2 raised to 3. So how many times 1 by 2 basically? How many times 1 by 2 coming in the expression?
3.
So 3 times. And if we have 2 raised to n, then n times. That is just simple observation. So 1 plus n by 2. So what is the conclusion? X2 raised to n is greater or equal 1 plus n by 2. And this is true for each n. No problem, whatever n you select. You choose n3, 4, 5, whatever. Every time this is going to happen. Right? And therefore, since xn is an increasing sequence, can we say that xn is unbounded? Because the left hand side is unbounded. 1 plus 1 n by 2 is unbounded. Since 1 plus n by 2 is unbounded. Correct? Because smaller thing, 1 plus n by 2 is unbounded, because if your n larger and larger, 1 plus n by 2 becomes larger and larger. And x2 raised to n is a larger quantity. Correct? And therefore,
Yes.
and so therefore sequence is unbounded. So therefore xn is not bounded above. Okay, one ambiguity could be, suppose we are just looking at x2, we are looking at x4, x8, x16, right? x2 raised to n. We are just looking at these terms. What about the in-between terms? x3, x5, x6, x7. What about the in-between terms? Do you understand? Because tendency of sequence is increasing. Tendency of sequence, we have already verified that sequence is increasing, and therefore x4 is greater or equal x5, and therefore if x4 is larger, then x5 is certainly larger. Correct?
Yes, sir.
And therefore we are not worried about what about in between terms, because tendency of sequence is increasing, and therefore look at just few terms, not few but x2 raised to n terms. If these are unbounded, certainly all terms are unbounded, means the entire sequence is unbounded. Correct? And therefore, what is limit of sequence xn? It is monotonically increasing and not bounded above. What is a limit? Or you can say it does not exist. Okay, so is it clear?
Yes, sir.
Right, so you think about it later on and try to work out the calculations. It is examples exercise. Right, next time we'll see one more interesting example.